Get ready to be amazed. Elon Musk, the world's most daring innovator, has just revealed his most ambitious project to date. Forget electric cars. This is the game changer you never saw coming. Introducing the Tesla tank, a revolutionary creation that will make you rethink everything you know about warfare. Prepare for a revelation that could reshape global defense. Hybrid electric tanks are the next major leap in military vehicle technology, offering remarkable efficiency and agility over traditional fuel-thirsty tanks. These hybrid engines combine diesel with electric motors and batteries, addressing major issues like fuel consumption and mobility. The Abrams X technology vehicle is a prime example, showing a 50% reduction in fuel consumption compared to the M1 Abrams, which has notoriously high fuel needs. This shift to hybrid power enables tanks to travel longer distances and stay operational for extended periods without constant refueling, giving military forces a huge advantage in prolonged missions. Beyond fuel savings, hybrid electric tanks are also more reliable. Gas turbine engines like those in the M1 Abrams are complex and prone to failure, especially in tough battlefield conditions. Hybrid electric engines, however, are more dependable and require less maintenance, critical when repair facilities are scarce. With fewer mechanical issues, these tanks are less likely to experience downtime, ensuring they stay operational in high-pressure situations, all while reducing the logistical burden on troops. Another key advantage? Hybrid electric tanks are quieter. Traditional gas turbines are loud, making tanks easy for enemies to detect. Hybrid engines, on the other hand, operate at much lower noise levels, making stealth operations easier and more effective. This quieter operation makes tanks harder to spot, an essential trait for surprise attacks or operating near enemy lines. It also helps them avoid detection by drones and other surveillance technologies, tools that are becoming more common in modern warfare. In addition to boosting performance, hybrid tanks represent a shift toward sustainability in military operations. Reducing fuel consumption not only enhances operational effectiveness, but also minimizes the environmental impact of warfare. With fossil fuel supplies limited during long conflicts, hybrid electric tanks could pave the way for more eco-friendly combat vehicles, making them a crucial part of the next generation of military technology. What if this hybrid tank tech could revolutionize not only the battlefield, but the entire way we think about military innovation? The evolution of military technology has always been a key factor in the outcome of wars. From the introduction of firearms to the development of armored vehicles, each leap forward has dramatically changed how battles are fought. The tank itself, introduced during World War I, changed land combat by providing mobility, firepower, and protection, traits that continue to define tanks today. Now, as military technology continues to evolve, we're on the cusp of another monumental shift. Thanks to advances in electric vehicles and AI, Elon Musk is at the forefront of this transformation, reshaping the future of both civilian and military transportation. Imagine a world where tanks, long known for their massive fuel consumption, are replaced by electric-powered armored vehicles that are more efficient, agile, and adaptable. The rise of electric vehicle tech promises a seismic change in military operations, improving mobility, logistics, and battlefield strategies. Traditional tanks like the M1 Abrams or the Soviet-era T-72 are powerful, but they face many challenges, especially in modern conflicts like the Russo-Ukrainian War. Their size, fuel consumption, and reliance on complex supply chains are glaring weaknesses. Hybrid electric tanks could solve many of these problems, making them more fuel-efficient, quieter, and easier to transport. These innovations would enhance the strategic capabilities of military forces, reduce reliance on fossil fuels, and provide greater flexibility in modern warfare. Looking ahead, land warfare will be transformed by advanced military technologies, including AI, automation, and lightweight materials. AI-driven systems will take care of routine tasks, allowing tank crews to focus on mission-critical decisions. Meanwhile, hybrid engines and cutting-edge armor will ensure that future tanks are a perfect balance of firepower, protection, and mobility. The next generation of tanks will be faster, smarter, and more effective, ushering in a new era of military operations that will leave the past far behind. Tank design. Through the ages, tank design has evolved dramatically over the years, shaped by the ever-changing demands of modern warfare. During World War II, tanks were initially created for simpler roles, but as the war progressed, the increasingly complex battlefield pushed for more advanced designs. Early tanks like the British Matilda and the German Panzer were lighter, with less armor and smaller guns. However, as the war intensified, the need for greater firepower, protection, and mobility led to the creation of more powerful and heavily armored machines. The German Tiger and Soviet T-34 became iconic, combining enhanced firepower with innovative features like sloped armor for better protection and wide tracks for improved mobility on rough terrain. As tank technology advanced, so did battlefield strategies and tactics. The tanks of World War II showed the importance of versatility, with many nations adapting their designs to meet specific needs. For example, the M4 Sherman, which became the workhorse of the Allied forces, was designed for mass production and mechanical reliability, making it highly effective despite not being the most powerful tank. On the other hand, the German Tiger, famous for its powerful 88mm gun and nearly impenetrable armor, was a symbol of German strength, but it suffered from mechanical issues that limited its effectiveness in combat. The evolution of tanks during this period reflected the balance between firepower, armor, and mobility, each element playing a crucial role in the success of tanks in different operational contexts. Even after World War II, tank design continued to evolve, driven by the geopolitical tensions of the Cold War and the ongoing arms race between superpowers. Tanks increasingly became more offensive-oriented, with a focus on survivability and technological advancements. For example, the M1 Abrams, introduced in the 1980s, revolutionized tank design with its composite armor and powerful 120mm smoothbore gun. The armor, made of layers of ceramic and reinforced steel, made it one of the most formidable tanks, capable of withstanding enemy fire and operating under extreme conditions. Meanwhile, the Soviet Union produced the T-72 and T-80, which focused on firepower and reliability to ensure the USSR kept pace with Western technological innovations. By the late 20th century, the trend toward lighter, more maneuverable tanks gained traction as militaries recognized that speed and agility were just as critical as firepower. Tanks like the South Korean K2 Black Panther and Japan's Type 10 reflected this shift, using composite materials to reduce weight while maintaining durability. The K2 Black Panther, weighing 55 tons, is a prime example of a modern tank capable of high-speed warfare, enhanced by advanced fire control systems. Looking ahead, future tanks will prioritize mobility and maneuverability on complex, dynamic battlefields. Gone are the days of heavy, clunky tanks. The next generation will feature sleek, efficient designs, better suited for modern and future combat conditions. The historic impact of tanks in warfare tanks have long been synonymous with modern warfare, and their impact on the battlefield cannot be overstated. The introduction of tanks during World War I was a game-changer in military strategy, but it was in World War II that their role truly became transformative. Tanks revolutionized the way wars were fought, offering unmatched mobility, firepower, and protection. They enabled armies to break through entrenched defensive lines and conduct both offensive and defensive operations with greater efficiency. The arrival of tanks changed the very nature of land warfare, making them indispensable in both strategic and tactical operations. During World War II, tanks played a key role in many critical campaigns. The use of tanks in Germany's Blitzkrieg tactics was revolutionary, allowing for rapid breakthroughs and overwhelming enemy defenses with precision and speed. On the defensive side, tanks were crucial in holding strategic positions, using their armor and firepower to resist enemy advances and secure vital areas. For example, in the European theater, tanks were essential during the D-Day landings, providing cover for advancing infantry and helping secure the beachheads. The mass production of tanks by major powers like the United States, the Soviet Union, Germany, and Britain gave the Allies a significant advantage. The M4 Sherman, produced by the US, became one of the most reliable and iconic tanks of the war. Its simplicity, mechanical reliability, and ease of production made it a key player for the Allies. In contrast, the German tanks, the Tiger and Panther, were powerful but prone to mechanical issues, and their sophistication made them harder to produce in large numbers. The Soviet T-34, known for its sloped armor and wide tracks, was especially effective on the Eastern Front, offering a balance of mobility and firepower. The GEE. The role of tanks in modern warfare. Tanks have long been the cornerstone of ground combat and strategic operations, playing a crucial role in conflicts like the Russo-Ukrainian War. Even though their traditional strengths, mobility, firepower, and protection remain valuable, they face new challenges on the battlefield. Modern tanks, such as the M1 Abrams and the T-72, are essential for breaking through enemy lines, securing territory, and supporting infantry. However, these heavily armored vehicles are increasingly vulnerable to modern threats like advanced anti-tank missiles, drones, and other cutting-edge weaponry, which pose significant risks to their dominance in land combat. Despite their immense power, tanks are becoming more complex in modern warfare. Their size and fuel consumption create substantial logistical challenges, especially during prolonged operations where mobility and resupply are critical. Tanks like the M1 Abrams, weighing between 67.6 and 73.6 tons, are highly effective but struggle to maneuver across softer terrain like mud or snow. Their massive weight also makes them difficult to transport, requiring specialized equipment and careful logistical planning. The ongoing Russo-Ukrainian War has exposed the vulnerabilities of conventional tanks in modern conflicts. While modern tanks are equipped with advanced armor and weaponry, they are not invincible. Over 8,000 Russian tanks have been destroyed or disabled, illustrating that, despite technological advancements, tanks remain vulnerable to modern anti-tank weapons. As a result, military engineers are re-evaluating tank designs to better address emerging threats like drones and precision-guided missiles. Future tank designs need to be more robust, versatile, and capable of adapting to these new threats. The lessons learned from current conflicts are pushing military strategists to rethink tank technology, focusing on improved protection systems, greater mobility, and more agility to stay relevant in modern warfare. Next-generation tanks will likely integrate lightweight materials, hybrid electric engines, and advanced AI systems to improve battlefield performance. These innovations will help tanks become more autonomous, efficient, and responsive to battlefield conditions, while also reducing the burden on tank crews. Hybrid electric propulsion, for example, will reduce fuel consumption and extend operational range, making tanks more effective in long-term conflicts. These systems will also allow tanks to operate more efficiently, freeing up personnel to focus on mission-critical tasks. Enhanced mobility and more efficient logistics will ensure tanks remain vital assets in modern warfare, while evolving to meet the changing nature of combat. The limitations of traditional tanks. Despite their formidable firepower and protection, traditional tanks come with significant limitations that hinder their effectiveness in modern warfare. One major drawback is their massive weight. Tanks like the M1 Abrams, which weigh around 70 tons, are powerful on the battlefield, but struggle to maneuver across soft terrain, such as mud, snow, or marshlands. Their size also creates logistical challenges, as transporting these heavy vehicles requires specialized equipment like cargo planes and transport vehicles, which can only move a limited number at a time. Another limitation is the high fuel consumption of traditional tanks. For instance, the M1 Abrams consumes about 1 gallon of fuel for every 0.6 miles traveled, making it highly inefficient. This excessive fuel demand presents a major logistical challenge, particularly in conflicts where resupply lines may be disrupted or difficult to maintain. The constant need for fuel makes it difficult to keep tanks operational during extended operations, and transporting large quantities of fuel to remote or resource-poor areas is both complex and resource-draining. Even with their advanced armor and weaponry, traditional tanks remain vulnerable to modern anti-tank weapons. The Russo-Ukrainian War has demonstrated that even the most powerful and well-protected tanks, like the M1 Abrams or the T-72, can be brought to a halt by anti-tank missiles, drones, and other high-tech weapons. Over 8,000 Russian tanks have been destroyed or disabled, highlighting the vulnerability of even the most advanced tanks to emerging threats like precision-guided missiles and autonomous weapon systems. The scale and complexity of conventional tanks also create significant maintenance and operational challenges. Heavy tanks require large crews, specialized repair teams, and frequent maintenance, all of which are costly in terms of military resources, especially during prolonged conflicts. Additionally, transporting these massive vehicles over long distances, especially by air, requires extensive coordination and resources, further complicating their deployment in different theaters of operation. These limitations have led military forces to reconsider traditional tank designs and explore innovative solutions to overcome these challenges. Advancements in tank protection and stealth technology, as well as the development of more efficient and agile armored vehicles, are essential to adapting to the evolving nature of modern warfare. With emerging threats and the need for more flexible, autonomous designs, future tanks will likely evolve to meet the demands of an increasingly complex battlefield. Modern tank protection and the future of armored warfare. Traditional armored vehicles, once nearly invulnerable to battlefield threats, now face sophisticated challenges. Tanks that were once impervious to most dangers must contend with advanced anti-tank missiles, drones, and precision-guided rockets that can penetrate even the heaviest armor. To counter these emerging threats, modern tanks are equipped with cutting-edge active protection systems, APS. For example, Israel's trophy system detects incoming projectiles and neutralizes them before impact. This system deploys jamming signals, smoke grenades, and even counter projectiles to intercept and destroy anti-tank missiles, offering a crucial line of defense against modern weaponry. In addition to APS, stealth technology has become a vital component in enhancing the survivability of tanks. As the battlefield evolves, tanks need to become harder to detect, not only by the human eye, but also by electronic surveillance and targeting systems. New stealth technologies are being developed to reduce a tank's heat, noise, and electromagnetic signatures, making it far more difficult for enemy forces to pinpoint its location. By blending into the surrounding environment or masking their presence, tanks can avoid detection and gain the element of surprise. These stealth capabilities are especially valuable when operating close to enemy lines or in highly contested areas. Advanced camouflage systems are also in the works to make tanks even more elusive. Israel, for example, has been developing adaptive camouflage technology that changes the appearance of the tank to match its surroundings in real time. This allows tanks to blend into various environments, such as urban landscapes or forests, making them harder to target. As drone and satellite surveillance technologies continue to advance, the need for such adaptive camouflage will only increase. These advanced techniques will give tanks greater freedom of operation while reducing the risk of detection. The future of tank protection also lies in lighter, advanced materials that enhance defense without sacrificing mobility. Innovations in armor technology, such as synthetic resins, ceramics, and composite materials, are creating stronger yet lighter armor plates. These materials offer superior protection against incoming fire while reducing the weight of the tank, leading to better flexibility and easier transportation. This shift addresses some of the long-standing criticisms heavy armor has faced in terms of mobility. The integration of advanced armor, APS, and stealth technology will ensure that future tanks remain effective against the increasing sophistication of modern weapons, proving that tanks still have a vital role on the battlefield. AI and automation in tanks. The integration of artificial intelligence, AI, and automation into tanks marks a monumental shift in their operation. Traditionally, tank crews were responsible for everything from navigation and target acquisition to maintenance and combat operations. With AI, many of these tasks are being increasingly handled by intelligent systems, allowing human crews to focus on more strategic and mission-critical decisions. AI-driven systems can enhance tank performance by providing real-time data analysis, optimizing route planning, and improving targeting accuracy. As AI becomes more integrated, future tanks may operate with greater autonomy, improving their efficiency and effectiveness in combat situations. Routine operations like diagnostics, maintenance scheduling, and battlefield management can be handled by onboard AI systems, reducing the workload on human operators. This shift not only enhances operational efficiency, but also ensures tanks remain in peak condition without the need for constant human oversight. By offloading routine tasks to AI, human crews can dedicate more time to adapting to battlefield dynamics and making faster, more informed decisions. The push towards automation also allows tanks to operate with fewer crew members, which is particularly important as military forces move towards smaller, more agile armored vehicles. One of the major advancements with AI integration is the potential for tanks to be optionally manned or fully autonomous. The U.S. Army's Optional Manned Fighting Vehicle (OMFV) program, designed to replace the Bradley fighting vehicle, is an example of this shift. The OMFV will be built on an open architecture, enabling it to be easily upgraded with new technology and allowing for minimal human interaction. It will rely heavily on AI systems for tasks typically handled by human crews, offering better protection, more firepower, and a reduced risk to personnel. AI and automation will also enhance how tanks interact with other military units. Tanks equipped with AI will be able to communicate and coordinate seamlessly with infantry, air support, and artillery, leading to better synchronization and more precise attacks. As AI evolves, it will help tanks adapt to the ever-changing dynamics of warfare, sensing real-time data and adjusting strategies accordingly. With AI at the forefront, tanks will transform from heavy machinery into highly sophisticated autonomous platforms capable of executing complex tasks with speed and accuracy. The evolution of tank armor and firepower. The evolution of tank armament and firepower has been crucial to maintaining the relevance of armored vehicles in modern warfare. Historically, tanks were equipped with 75mm and 88mm guns, which evolved over time into the powerful 120mm smoothbore guns used in modern tanks. This progression in firepower has ensured that tanks remain formidable on the battlefield, capable of engaging a wide range of targets with precision and force. As the demands of modern warfare continue to evolve, so too must tank designs, incorporating advanced protection, stealth, and automation technologies that allow them to stay effective in an increasingly complex and dangerous battlefield environment. By combining cutting-edge innovations in armor, AI, and weaponry, future tanks will continue to play a crucial role in modern military operations. The evolution of tank armament and future design. Modern tanks such as the M1 Abrams and T-80 typically feature powerful cannons. However, as the demand for greater firepower increases, tank armament is shifting toward larger calibers. One notable development in this area is the Main Ground Combat System, MGCS, a joint project between France and Germany, which aims to equip future tanks with a 140mm cannon. This upgrade would significantly enhance the tank's ability to engage targets at longer ranges, providing more devastating firepower and improved precision, ultimately shifting the balance of power on the battlefield. The transition to larger caliber guns isn't just about increasing the size of the cannon. Tank firepower is also being redefined through the integration of advanced ammunition types and the implementation of autoloaders. The move to 140mm guns reflects a broader trend in the industry toward improving tank lethality, enabling them to destroy enemy vehicles, fortifications, and even aircraft with greater efficiency. Autoloaders, which automate the process of loading shells into the cannon, are a key part of this shift. By eliminating the need for a human loader, autoloaders increase the speed and reliability of firing, a crucial factor for tanks in fast-paced combat situations. One advantage of autoloaders is that they simplify tank operations, allowing crews to focus on more strategic tasks rather than manual loading. As modern tanks become smaller and more compact, the efficiency of autoloaders becomes increasingly important, allowing tanks to maintain high rates of fire without needing additional crew members. While some believe autoloaders may be less reliable than human loaders, the benefits in speed, accuracy, and reduced manpower are significant, especially as tank designs continue to prioritize agility and lighter weight. Beyond the weapons themselves, tank armament is also evolving in response to the growing importance of electronic warfare and advanced targeting systems. Modern tanks are equipped with fire control systems that significantly enhance targeting accuracy, even while on the move. These systems use data from various sensors, such as radar and infrared tracking, allowing tanks to strike targets from longer distances with greater precision. The integration of AI and automation plays a key role in improving tank firepower by enabling these systems to analyze battlefield data and make real-time adjustments to enhance effectiveness. Future tank designs will rely on a combination of advanced weaponry, intelligent targeting systems, and automated processes to maintain a decisive advantage in combat. However, tank design isn't just about firepower anymore. It's about agility and adaptability. As military forces face increasingly unpredictable challenges, tanks must be reimagined to operate with speed and precision. A major advancement in future tank design is the shift toward modular platforms, which allow for quick upgrades and easy adjustments depending on the mission. These modular tanks could be customized. In addition to modularity, autonomous capabilities are expected to play a major role in the next generation of tanks. While fully autonomous tanks are still years away, improvements in AI and robotic systems will allow tanks to operate with minimal human intervention. AI can help identify targets, make decisions, and even navigate, reducing the cognitive load on tank crews. This would open up the possibility of unmanned ground vehicles, allowing tanks to carry out missions without direct human oversight. As AI technology advances, autonomous operations on the battlefield will become increasingly feasible, significantly improving tank effectiveness while minimizing the risk to human lives. Future tank designs will also focus on rapid deployment. The ability to quickly move tanks from one location to another is critical in modern warfare, where surprise and adaptability can make all the difference. Transportability will become a key design consideration, with tanks becoming lighter and more compact for easier deployment in diverse situations. Conclusion. In summary, as tank technology evolves, future designs will emphasize not just firepower, but also agility, modularity, AI integration, and ease of transport. The tanks of tomorrow will be faster, more flexible, and smarter, better equipped to handle the complexities of modern combat. With these advancements, tanks will continue to play a crucial role on the battlefield, but they'll be more effective than ever before. Thanks for watching. If you enjoyed this video, be sure to like, comment, and subscribe for more exciting content. We'd love to hear your thoughts, so drop a comment below and make sure to check out the next video for more fascinating insights. See you next time.